Hi everyone, this is Dr. Nak again, and we're going to go over our practice final exam, the second portion of it. And for this portion, you can use your scientific calculator on the whole entire exam. Okay, number one. For the trig function y equals 3 sine of 2x minus pi plus 1, find the amplitude, period, and in any vertical shifts of the graph. Sketch one cycle of the graph and label key points. Okay, so since we're given the sine graph, let me just draw the mother graph of y equals sine of x. And one cycle, I'm going to draw this on the interval from 0 to 2 pi. All right, so that will be the mother graph. Now the amplitude is nothing but the absolute value of the coefficient on your sine. So in this case, absolute value of 3 is just 3. So that's going to be our amplitude. Meaning the height of the graph, the mother graph, is going to go from 3 to -3 or -3 to 3. Okay, so let me just draw that one out. So if I have y equals 3 sine of x, so this is what's going to happen. So again, this is 2 pi, 3 pi over 2, and then pi over 2. Okay, now to determine the period, what you should do is put the argument of sine, which is 2x minus pi, between 0 to 2 pi. Then solve for x. Okay, to solving for x, we need to add pi to both sides. And solving for x, we need to multiply everything by a half. Alright, so this tells you that instead of drawing the graph from a final graph from 0 to 2 pi, you're going to be graphing it on the interval of pi over 2 to 3 pi over 2. So period is going to be 3 pi over 2 minus pi over 2, which will be just pi. So I'm going to fill that out. Okay, so now let's get started on the graphing. Okay, so let's just look at the y equals 3 sine of x. Now, if I go y equals 3 sine of x plus 1, what's going to happen is you need to shift that whole entire graph of y equals 3 sine of x 1 unit upward. So this is what's going to happen. Let me see if I can draw this out. You know my drawing skills by now. All right, I can do this. Okay, so instead of starting from 0, what's going to happen is your graph's going to start from 1. So this point right here is going to be 0, 1. X is 0, y is 1. All right, now at pi over 2, instead of 3, you're going to go 1 unit upward. So it's going to be at 4. So this point is going to be pi over 2, 4. All right, and then at pi, you're going to go back to y equals to 1. And at 3 pi over 2, if you shift the bottom portion 1 unit upward, it's going to be at -2. Y equals -2, so this is completely drawn off the scale. Sorry about that. So this point right here is 3 pi over 2, -2. And then you're back to y equals to 1. So here you're going to have 2 pi, 1. Not too shabby. All right, so now let's shift this graph pi over 2 units to the right, and that is going to be our final graph. So if I do that, okay, you're gonna start from pi over 2, and you're gonna end at 3 pi over 2, and then you're gonna have to break this off into 4 equal interval. So in this case, this point is what, 3 pi over 4? And this is going to be pi, and then 5 pi over 4, and 3 pi over 2. Okay, so now what's going to happen is this. Okay, we're going to start out with y equals to 1. So this point is going to be pi over 2 comma 1. And at 3 pi over 4, y value is going to be 4. So here you're going to have 3 pi over 4 comma 4. And at pi, your y value is going to go back down to 1. So here you're going to have pi comma 1. And at 5 pi over 4, your y value is going to be negative 2. And at 3 pi over 2, your y value is going to be back at 1. Alright, so our final graph is going to look something like this. That's pretty good. I'm pretty impressed with my sine graph right now. Alright, but anyways, let's go with the horizontal and vertical shift. So of course our vertical shift is by just 1 unit upward. And horizontal shift, what you have to do is what? Shift the whole entire graph by pi over 2 units to the right. So horizontal shift. Okay, I'll just write it as shift by pi over 2 to the right. I think this is good enough. Alright, so that was number 1. Number 2, given the equation that state the type of conic section represented by the given equation, sketch the graph of the equation, label the center, vertices, co-vertices, and foci. Label the points using exact values. Okay, so let's just look at that equation a little bit, and that is clearly an ellipse, where the major axis is going to be parallel to the y-axis. Alright, so that, which means that you're gonna have a tall ellipse instead of the squashed down ellipse. Alright, so keep that in mind, and then again, you can use your conic sheet to do this problem if you feel more comfortable that way. Okay, so first, let's go with the type of conic. That was an ellipse. Alright, now center is going to be what? X is 1 and y is negative 2. Sorry, center is denoted by h comma k. And then foci, the formula for that will be h comma k plus or minus c. So here you're going to have 1 comma k is negative 2 plus c. Oh goodness, I need to find the value of c. Alright, so let's determine those values, a's and b's and c's. So right now we have h equals to 1, k equals to negative 2. Now a is the square root of 4, which is going to be 2. B is square root of 1, which is just going to be 1. And then our C the formula for that is going to be square root of a squared minus b squared. So this is going to be what? Square root of 3. Okay, so I think we can fill this out now. So the foci is going to be h comma k plus or minus c. So you're going to have 1 comma negative 2 plus c is root 3. And then 1 comma negative 2 minus square root of 3. Okay, now let's go with the vertices. Now the vertices are given by h comma k plus or minus a. So in this case, what do we got? 1 comma negative 2 plus 2, and then 1 comma negative 2 minus 2. So it looks like our vertice is going to be 1 comma 0 and 1 comma negative 4. All right, so let me just draw that out, and then we can determine the co-vertices pretty easily if I draw this out. So let me see. Okay, so let me see. The center is 1 comma negative 2, 1 comma negative 2. So this is the center. And vertices are 1 comma 0. I'm just going to write it as v equals 1 comma 0. And also 1 comma negative 4. Okay, so again, notice that the major axis is parallel to the y-axis, and then distance from here to here is the square root of 4, which is going to be 2. Oops, sorry, and then from here to here is going to be 2. Let me just erase this portion. Okay, now to determine the co-vertices, the denominator under x minus 1 squared is 1, and square root of 1 is 1. So from the center, what's going to happen is you're going to go 1 unit to the left and then 1 unit to the right. So that's going to be your co-vertices. So it looks like our co-vertices, I'm just going to write it as CV, co-vertices, is 0 comma negative 2. And then this co-vertices here is going to be what? 2 comma negative 2. Okay, so let me just connect the dot. That's not too bad either. All right, so anyway, so co-vertices are 0 comma negative 2 and then 2 comma negative 2. Number 3, establish the trig identity. Show all of your work in organized manner to receive any credit. Okay, so what I'm going to do is I'm going to start this problem from the left-hand side, since left-hand side looks way more complicated than the right. So let me just copy the problem. All right, so let's see what we can do here. I would combine this and make it into a 1 fraction. So the least common denominator will be what? 1 minus sine of x, and then 1 plus sine of x. So that means I need to multiply 1 plus sine of x by 1 plus sine of x. And then minus, I have 1 minus sine of x. And looks like what? I need to multiply here by another 1 minus sine of x. Okay. All right, so now let's see what we can do. Maybe multiply this out. Okay, so here you're going to have what? 1 plus 2 sine of x plus sine square of x. and then minus. Now be careful here when you multiply this, make sure to put a bracket around it because you need to distribute that minus sign. So here you're going to have minus bracket 1 minus 2 sine of x and then plus sine square of x. And don't forget the denominator. The denominator is going to be, let me see, 1 minus, I'm multiplying this out, sine square of x. All right, so now let's see what we can do. Okay, I'm going to distribute the negative sign in now. All right, so let me see. 1 minus sine square of x, that's same thing as cosine square of x. So I'm just going to replace that. And if it doesn't work out, I'll convert it back into 1 minus sine square of x. Okay, so now let's see what we can do here again. We can kill the ones. And what else can I kill? Sine squared. Kill, kill. And is that it? I think that's pretty much it. So what do we have left over here? So it looks like we're going to have 4 sine of x over cosine square of x. Okay, but the cosine square of x is nothing but cosine of x times the cosine of x. All right, so we're almost home. So this is same thing as what? 4 times, I could separate this into sine of x over cosine of x, multiplying here by 1 over the cosine of x. I'm just separating it. So sine over cosine is tangent. So here you're going to have 4 tan of x, multiplying here by 1 over cosine, which is secant of x. Good, which is going to be the right-hand side. Number 4, solve the equation algebraically. State the solutions on the interval from 0 to 2 pi. All right, so first what I will do is put the 1/2 on the right-hand side. So I'm just going to go sine of 2 theta equals 1/2. All right, now I'm going to apply the sine inverse on both sides, and here you're going to have 2 theta equals sine inverse of 1/2. Okay, so now I need to compute what the sine inverse of 1/2 is. So let's just call that one y. Okay, and as a side work, I'm going to say let y be sine inverse of 1/2. So that implies that sine of y is going to be 1/2. Okay, so it looks like sine is what? Opposite over the height, or if you like x, y, and r, this is same thing as what? Y over r. And this is root 3. Oh, one more thing. Sine's positive in quadrant 1 and quadrant 2. So this is going to be our y. And y is what? Pi over 6. And here you're going to have the same situation. So from here to here is pi over 6. So that means one of the angle is going to be pi over 6, and then another one is going to be pi minus pi over 6, which will be what? 5 pi over 6. All right, so let me just clean it up a little bit. So what we just discovered is this. So we have y equals either pi over 6 or 5 pi over 6. So that was my little side work. All right, now let's put them all together. Okay, so I'm going to put it in here. So what do we got? We have either 2 theta equals pi over 6. Since I want to get all the solutions on the interval 0 to 2 pi, I'm going to make this into plus 2 pi k, where k is an integer. And then another one is going to be 2 theta equals 5 pi over 6 plus 2 pi k. And k is an integer. Alright, now I want to solve for theta, so I need to divide everything by 2 or multiply everything by a half. So here you're going to have theta equals pi over 12 plus pi k. And then theta equals 5 pi over 12 plus pi k. Alright, let me just box this. Alright, now let's see what kind of values that we can squeeze out of this that are in the interval of 0 to 2 pi. So let me just start out with k equals to 0. Oops. Alright, so when k equals to 0, our theta is going to be pi over 12 plus 0. I'll just write it as plus 0, and 5 pi over 12 plus 0. So I believe that those are definitely inside of the interval of 0 to 2 pi. So these are keepers. Okay, so now let's go with when k equals to 1. Our theta is going to be pi over 12 plus 1 times pi is pi. And here you're going to have 5 pi over 12 plus pi. Okay, so this is going to be what? 13 pi over 12. And then 17 pi over 12. Are they inside of 0 to 2 pi? Yes. Keeper. Alright, so now let's go with k equals to 2. When k equals to 2, our theta is going to be pi over 12 plus 2 pi. That's clearly going to be outside of 2 pi. And then this is going to be bigger than what we just got above. Oops, that's 29 pi. This is not inside of 0 to 2 pi. Alright, so it looks like our solution set is going to be, who can we keep? Pi over 12, 5 pi over 12, and 13 pi over 12, and then 17 pi over 12. And here's our solution. Number 5, solve the systems of nonlinear equation by the method of your choice. Okay, so let me take a look at it. How about by substitution, since you're given the top equation by 3x squared plus y squared equals to 12, and you're already given y squared equals to 9x. So what I'm going to do is I'm going to plug 9x in place of y squared into the top equation. So here I'm going to have 3x squared plus 9x, and I'm going to bring the 12 on the left hand side by subtracting it. There you go. Okay, now can we factor this? I think if you factor out the 3, then what do we get? X squared plus 3x minus 4 equals to 0. And I believe we can factor this. Which one is it? So this better be 4 and a 1. Good. Alright, so then what? Our x is either negative 4 and x is 1. Let me just box our proposed solution. Okay, it is very important that you check your proposed solution because some may not be a solution set. Okay, so let's go with when x equals to negative 4. I'm going to plug this into either one of the equation. So I'm going to pick the easier looking one, which is the bottom equation. So I'm going to plug it in. Y squared equals 9 times x, which is 9 times negative 4. That implies that you're going to have y squared equals negative 36. Then here you're going to have y equals to what? Plus or minus 6i, which is the imaginary solution, so we need to throw that away. Bye-bye. Okay, so that means x equals to 4 is not going to be part of your solution. Now let's check when x equals to 1. Y squared equals 9 times 1. So here we're going to have y equals to what? Plus or minus 3. Okay, keeper. Alright, so the solution is going to be when x is 1, y is positive 3, and when x is 1 and y is negative 3. So that's going to be our solution set. Number 6, find the nth terms of the sequence a sub n whose first 4 terms are given by that. So this means the first term, when n equals to 1, it's 1. When n equals to 2, it's negative 1/4. N equals to 3, it's positive 1/9. And when n equals to 4, it's going to be negative 1/16. So notice that we're going to get an alternating sequence for sure because it's going from positive, negative, positive, negative. All right, so let's first take care of that part. So the alternating part is always going to be denoted by negative 1 to the certain power. Now, if I just have an n here, when n starts from 1, negative 1 to the first power is negative 1, so the first term is going to be negative. So that's not good because our first term is a positive 1. So if I add 1 to it, then it works because when n equals to 1, you're going to have negative 1 whole quantity to the second power, which is going to give us a positive value. All right, so that's going to be our alternating part. Now let's take a look at the denominator. Luckily, all the top is, when numerator is 1. So the bottom, so when n equals to 1, it's 1. N equals to 2, it's 4. N equals to 3, it's 9. And n equals to 4, it's 16. Do you see a pattern? Do you see that 4 is 2 squared? 9 is 3 squared. 16 is 4 squared. So it looks like our denominator is going to be n squared. So if you want to test it out, you can always check by plugging in your n values from 1, 2, 3, 4 to make sure that it is going to match up with what's given to you. But anyways, our answer in this case, our sequence an is negative 1 to the n plus 1, whole thing over n squared. I'm just going to keep it that way. Okay, number 7, find the sum. Sum n starting from 4 to 8 of negative 1 to the n plus 1 times 1 over 2n. Now to me, the easiest way to do is just expand it out. When n is going to start from 4, so let me see. When n equals to 4, just plug it in. You're going to have what? Negative 1 to the 4 plus 1 times 1 over 2 times 4. And then sum means add. A sigma notation means add. So I'm going to go add. When n equals to 5, you're going to have negative 1 to the 5 plus 1 times 1 over 2 times 5. And then plus n equals to 6, you're going to have negative 1 to the 6 plus 1 times 1 over 2 times 6. And then plus, so in this case, this is going to be n equals to 7, negative 1 to the 7 plus 1 times 1 over 2 times 7. And then plus, when n equals to 8, that's where when you stop, then here you're going to have negative 1 to the 8 plus 1 times 1 over 2 times 8. All right, so then what do we get here? So here it looks like we're going to have the first term, which is when n equals to 4, you're going to have negative 1 over 8. Plus when n equals to 5, you're going to have positive 1 over 10. And then when n equals to 6, minus 1 over 12. And then when n equals to 7, positive 1 over 14. And when n equals to 8, it is minus 1 over 16. All right, so if you combine this all together, what I get is negative 167 whole thing over 1680. Please check my work. I make mistakes all the time. And here it is. Number 8, find the first term and the common difference of the arithmetic sequence. I can never say that word right. But anyways, then it's supposed to be find a formula for the nth term. Sorry, this is find. All right, so the 14th term is negative 1 and 18th term is negative 9. So what we're given is a sub 14 is negative 1 and a sub 18 is negative 9. So those are the information that's given to us. Now, key is this. Key is to know that formula for the nth term of an arithmetic sequence. Okay, memorize this formula. So we got a sub n equals a sub 1 plus n minus 1 times d, where d is the common difference. Okay, so I think we're ready to do this. So let's use the fact that a sub 14 equals to negative 1, and I'm also going to use the formula together, and we're going to have a sub 14 is a sub 1 plus 14 minus 1 times d, but we already know that a sub 14 is negative 1, so I'm going to set that equal to negative 1. And then also a sub 18, it's going to be negative 9, but if I use the formula, this is a sub 1 plus 18 minus 1 times d equals to negative 9. Okay, so now let's just simplify this a little bit. So that implies that, let me see, a sub 1 plus 13d equals negative 1, and a sub 1 plus 17d equals negative 9. Okay, so notice that we got the systems of equations here. So first, what we want to do is trying to find the common difference, which is d. So how about we multiply the top equation by negative 1 and get rid of a sub 1. So if I do that, I'll write every step out. Okay, so then, sorry, there was a minus sign there. So then this is going to cancel out. And what do we have left over here? 7d equals to negative 8. So that implies that our common difference is going to be negative 2. Let me just box that in red. All right, now let's use the information that were given to us to find a sub 1. Since we know that a sub 14, the formula was what? a1 plus 13d. Now that was what equals to negative 1, but we just found out the value of d. The common difference is negative 2, so that implies that a sub 1 plus 13 times negative 2, this is going to be negative 1. So that means what? a1 and minus 26 equals to negative 1, add 26 on both sides. So that means A1 must be 25. Okay, so let's fill in the blanks here. So the first term, A sub 1, is going to be 25, and common difference is negative 2. Okay, now the formula for the nth term. Alright, so let's go back to the formula. A sub n equals A sub 1 plus n minus 1 times t. So our A sub n is going to look like A sub 1. Let me just write everything out. Plus, so an times t. Alright, so it looks like this is going to be what? A sub 1, we just discovered that that's 25. And then plus n minus 1, and then our common difference was negative 2. Okay, so simplified a little bit. And what do we get here? Minus 2n and then plus 2. Alright, so it looks like our A sub n is 27 minus 2n. And that's going to be the answer. Number 9, determine whether the infinite geometric series converges or diverges. If it converges, find its sum. Now, converges means that when you keep adding those terms of a sequence, it's going to be a finite number. And diverges means that if you keep adding those list of numbers, it's either going to blow up to infinity or the sum does not exist. That could happen sometimes. But anyways, let's just get started on this. Now, there are two things that you're going to have to know. So the first one, make sure to know these two. Nth term of geometric series. All right, memorize this. A sub n equals A sub 1 r to the n minus 1. Where of course r cannot be 0. All right, and the second thing is that if absolute value of r is less than 1, geometric series is going to converge. Geometric series, k going from 1 to infinity of A sub 1, r to the k minus 1 converges with sum being A sub 1 over 1 minus r. Alright, so those are the two key things that you need to memorize. Alright, so let's get started on this problem. Now, to find the nth terms of the geometric series, notice that our first term, A sub 1, is 3. A sub 2 is 1. And then A sub 3 is negative 1/3, and so forth. Okay, so let me just write that out. We know that A sub 1 is negative 3. Now, notice that when n equals to 2, A sub 2 is 1. Okay, so our nth terms of the geometric series formula, our A sub n, which is given by what? A1 r to the n minus 1. Now this is going to become A sub 2 equals A sub 1, but our A sub 1 is negative 3. So you're going to have negative 3 times r to the, now n is 2, so you're going to have to replace n with a 2. So you're going to have 2 minus 1. But we know that A sub 2 better equal to 1. Alright, so now what do we got? Solving for this, we have negative 3 to the r equals to 1. So our r is going to be negative 1/3. I'm going to box this because this is a very important information. All right, so now since absolute value of r, which is what absolute of 1/3, is less than 1, geometric series converges. And with sum of a sub 1 over 1 minus r. That's the formula for that. So our sum is going to be a sub 1, which is what? -3. And then our 1 minus r is going to be 1 minus, be careful, your r is negative, so here you're going to have to go 1 minus 1/3. So which is -3 over 1 plus 1/3, which is 4/3. So looks like you're going to have -6 over 4. And the answer is going to be looks like it's going to be -3 over 2. So now this is the sum. All right, now let's put this together and let's try to come up with the geometric series. Okay, so the geometric series better look something like this. All right, so with that said, looks like our geometric series is going to look like k starting from 1 to infinity, a sub 1 is -3, and then r is -1/3, and to the k minus 1. All right, so that's going to be our geometric series. And since absolute value of r was 1/3, which is less than 1, you're able to compute the actual infinite sum, which is going to be -3 over 2. If you're taking more math classes in the future, you will see this material sequences and series again in second semester calculus, which is one of my favorite topics. Anyways, I think this was it. This is the whole second portion of the practice exam. If I made some mistakes or something like that, please let me know. And go kick some butt. Be confident, stay positive, and give it all you got on the final. You can do it. If I can do it, you can do it. Good luck. And if you have any questions, please let me know.